Our final second semester senior design team is going to talk about martial art smart glove. Uh-oh. Let's welcome them. We get out of the way.
Hi everyone, we're going to talk to you about the martial arts smart glove. My name is Dana Brown. This is Todd Millard, Margaret Willard, Ikra Nawabi, and I covered the testing and the idea. I'm actually a martial arts self-defense instructor, so we wanted to fill a need, basically. Currently, there's nothing on the market that exists for something that is portable, light, easy to use, and is affordable, and be set up in a matter of seconds rather than being calibrated for hours when having to come in, all that fun stuff. Additionally, this particular device will measure impact force so that someone can see how well they're progressing as they're going, rather than simply having some objective or subjective way of measuring that they have to fight somebody. Additionally, this is a good proof of concept for something that can be used in gaming, perhaps. You know, take your service, you can measure how hard you're hitting, that translates into something in the game. Todd covered the hardware side of this.
So, in order to come up with the solution, we used 4 flex force sensors located in the glove. And these sensors were kind of like a variable resistor. So they're about 50 mega ohms when there's no pressure on them. And then when there's pressure on it, it can come down to as low as about 20K. And so we used a voltage divider that was connected to a MSP430. So we took VCC from the MSP430 into the sensors. And the sensor is actually a 3-terminal sensor, but the center terminal is a no connect. So one side of it had power, the other side went to the voltage divider between it was a 1 mega ohm resistor, and so therefore that 4 of those sensors went onto analog pins on MSP430. So we have 4 analog pins that the 10-bit ADC would then read the values that were coming in. So we get a value between 0 and 1023, and so we decided based on the testing that we were going to throw out anything that was under 110 hex, which is about 272, I think. And so that way when you flex like this or do movements, you don't accidentally trigger saying that you had some force that you punched somebody. So then what we did is we then output those values into the UART on the MSP430 that went into the USB on the USB on the MSP430 on the launch pad. And we got a wireless USB system which would then send that signal wirelessly to a computer where we had Margaret, we worked on software studies.
So for the software, in order to interface with the MSP430, we used a hyperterminal called TerraTerm to see what outputs we were getting from the MSP430. Every time you punch with the glove, there's a burst of ADC values that show up in TerraTerm, and then TerraTerm outputs to a log file. The interface I designed reads live from that log file, processes the data, and then displays it in the GUI format. So based on 5 different brackets that we created, it'll tell you how hard you punched.
I work on the research and collaboration side, and how we were able to collaborate these sensors was we got hold of the Instron 4500 at the mechanical engineering lab, and that allowed us to put like a constant amount of force on the sensors and then get the corresponding ADC values, and we figured out that there's a logarithmic relationship between the ADC values and the foot counts. And an issue that we ran into was that we wanted a high degree of accuracy, and it was slightly deviating when we tested it out. And one of the reasons why we think that, we initially thought that it was deviating was because of the thickness of the glove. But when we took that into consideration as well and adjusted the given equation, we were still getting, slight deviations. So instead of giving like a numerical output, we decided that it would be a little more accurate if we went with 5 ranges. So we split up like all of the potential 0 to 1500 foot-pounds, which is what the sensor can take, into 5 different levels, and we even decided to name them just for fun. So level 1 is like computer science student, and then level 2 is a person, level 3 is an engineering student, level 4 is senior science judges, and level 5 is
Hulk smash!
So we can't wait for you guys to come out and try it out.
Yeah, come manifest it.
Any questions?
Why did you choose a 1 mega ohm if that being
ohm,
Oh, 50
and then it drops down to as low as 20K. So in that range, then we could get the distribution.
That was a comfortable value.
Yeah.
That turned out to be, it was described very nicely in the values of the.
Yeah, this was the best that we came out with. We tried several other resistances and we were getting, it was very, very difficult to get values that would give us.
Flat ones.
Yeah, exactly, yeah.